Hello. So I'm going to go over the software that we use at Fresno State for cyclic testing. I'm going to share my screen. Okay. So I'm going to go to File. Let me break this down. So we go to File, we go to Load. You can usually open a template. However, I have a file that I have already entered the information in it. So I'm just going to open that. It says project number 1, project name SRM, which is soil rubber mixture, count state Fresno, location Fresno. The description is 100% sand with 50 kilopascal confining pressure. I'm going to go to units and change the units to actually metric because that's what I'm using. And I'm going to say, okay. So I'm going to go to a specimen. The initial diameter, I'm going to enter those. I have already recorded them. The height is 152. Actually, I got this 150. Can I measure it? And for the diameter, I got 71.5. Okay, we have measured the specific gravity as 2.64. Actually, I'm just going to change. Yeah, that's actually correct. And we have the initial mass as 936 kilograms. Let me change this to what I have here. It's a little slightly different. Okay, so I'm just going to save this. Okay. Then we're going to go to water content. You can leave it as it is. Read table. So read table, you can read at different times. I'm just going to say at 0 second, 2 second, 10 second, 20 second, 60 second. Then I'm going to go to test parameters and we're going to start with initialization. We don't do consolidation A. It's going to skip that because we are going to leave it empty, this table. We're going to leave it blank. Then we go to saturation, and then we're going to go to consolidation B, but we do the consolidation B, so we have to enter the information for that. Here, this is 0, the membrane correction factor. If I change my units to English and apply, this is 2.1 in English, and that's what we got from when we bought the membrane. But when I'm using metric, then that number changes to an interesting number. So that's why you see that number. Then method A, here uniform, we go to initialization. Initialization is basically when we apply, some overall pressure. We're going to start with the 65 kilopascal and vertical stress 65 kilopascal, and sample pressure is going to be 35. So basically here your effective stress is going to be 30. Then you have stress rate and duration is 3,600 seconds, which is 1 hour. Then we're going to go to consolidation table. For A, we don't do anything. We leave it blank. We go to saturation. Pressure increment 30 kilopascal, pressure rate 0.5, minimum cell pressure 100, maximum cell pressure 250. And Then we need minimum saturation ratio 0.95. This is our B value. This is how we check if our soil is actually saturated. Then we go to consolidation B. We want the effective horizontal stress to be 50, effective vertical stress to be 50, stress rate 3.5, duration type volume, maximum duration 24 hours, minimum duration 30 minutes. Then the cyclic table, which I have this, I only defined one step with cyclic period 1 second, which is a 1 hertz, number of cycle, maximum number of cycles 100. I can change that to 500 as well, but I'm just going to keep it as 100. And a stress ratio amplitude 0.2. This is what I'm going to keep. And then shear table, you can leave. I'm just going to go to start. It's asking you to save it. So I'm going to save it. And also I put my notes here to make sure I don't miss anything. Before we, see, I'm so glad I checked. Before we start, we have to calibrate our sensors. So I'm going to go to calibrate and I see the summary here. And then I'm going to go to view and I'm going to go to view system. So here we need to make sure our sensors are connected. So I'm going to close because I connected the sensors. I'm going to close the system and open it again. Okay, so now you see, I'm not sure if you guys can see this table. Maybe not. But I opened the system monitor. So here I open the system and I can see the system monitor, and then I can go to calibrate and see the summary here. So we see two sets of rows here if you have that window open in system monitor. The first one, that's the engineering number that the machine gives, the code. And what you see, those are what we read in newtons. These are supposed to be 0 at the beginning. So we're going to zero this out. So I'm going to look at the load, my load window here in the calibration summary. I'm going to have to put 32795, what I see in the system monitor, and I'm going to apply that. And as you can see, the load changed to 0. So now I'm going to go to displacement 1. I'm going to change that number for displacement 1 to 19,214 and apply that. And as you can see, or I'm not sure if you can see, my displacement 1 becomes equal to 0. They usually change a little bit, so that's okay. I go to displacement 2, I have 14,837 or 840. It keeps fluctuating, and that's okay. And now the displacement 2 becomes 0. Now I'm going to go to cell pressure. That's 11,665. Apply. Now cell pressure becomes 0. Now I'm going to go to sample pressure. I'm going to put 32,650. And I'm going to apply that. That one became 0. And then sample feedback. And then that's 32,881. Apply. I'm going to upload and do OK. So now I kind of have zeroed out everything. Sample pressure 0, sample feedback 0. I believe we are good to run the test. I'm just going to check to see I don't want to forget anything. Okay, so I'm going to start the test. You can keep your system monitor open because that shows you what's happening. My supply valve is closed, my open valve, my output valve is open. Okay, so on the flow track, we have two flow track pumps. The first one to the left, that's for cell. The one to the right, which is for the sample and pressures, basically pore water pressure, that needs to be kind of, we can see how much, if it's full or how much water it has. You can go to position. So if you go to menu and then go to position on it, then control values, number 5, it tells you that the valve, the output valve is open and the supply valve is closed. And that's what we want. And to check the limit, you can go to menu, go to monitor, and then go to system. And it tells me that it's 98.3% full, and that's good enough for us. We don't need more. It usually keeps about a cup of water in it. And we also, there's a cylinder next to our pumps that we need to make sure that one is filled, and both supply and output pipes are in the water. So I'm just going to do that now. So that cylinder next to the pump is where the water goes to pump and gets out of the pump. Depends on when we are performing our test, when we're saturating, when we are, consolidating, and whatever happens to the water situation, that goes to that cylinder. Okay, so now I can start the test. So I'm going to go to run, and then I'm going to connect start. It wants me to save it, so I'm just going to save it in the same, under save name. It says press yes to initialize the flow pump. Press no to continue without initializing the pump. I think our pump is already initialized, but we can press yes here to do some initialization. You're going to hear some noises, and so it's emptying a little bit. I can see. So it went to 94%, but we don't need to empty it. We can just, so usually it's emptied because if it needs to, have some water going back to the pump, they want to make sure there is room for it. So I can see that it's, it's going to 86%, 85%. So probably, I'm not sure what's the setup, but we can usually set that up, that what percentage we want it to be. But I can just press OK here. I think we are good. So I pressed OK, and I have 76% now. Press yes to position the platen. Press no to continue without positioning the platen. I do want to position the platen, so I'm just going to say yes. It says press OK when ready, press cancel to abort it. I'm just gonna say OK. It says press OK when you're ready, press cancel to abort the test. Unlock piston. My piston is unlocked. That's a black knob. Then we can now see what is happening in the test. We can also view our graphs. So this is initializing phase.